Good morning. I am Karthik Chanapati and this is my presentation on the second physics lab project. Introduction. In this lab session, we were required to compare the results obtained from an experimental model and two computational models, one which took drag into consideration and one which ignored the effect of drag on an object that was falling downwards under the influence of gravity. Results. After comparing the different models, I observed that the drag-based computational model is more accurate than the one without the drag force. The physics principles which applied in this experiment were F equals ma, the drag force which was inversely proportional to the square of the velocity, terminal velocity, and motion in the y-axis is not affected by motion in the x-axis in the case of an object that is falling straight downwards. Experimental setup. So I used a basketball which weighed half a kilogram and the radius of the basketball was 12 centimeters and the axis that was used to measure was a negative y-axis. Physical model. In my experiment, as you can observe, my ball had a slight movement in the x-axis too, but as we learned in class, it does not affect the motion of the ball in the y-axis. And I have displayed my results here, and here we can observe that the motion is not exactly constant. The velocity of the ball is increasing due to gravity. The computational model. According to the computational model, I found out that the drag force actually causes the velocity to stagnate after a certain point. And in this scenario, we used a constant drag force. The comparison. So I compared the data between the experimental setup, between the model with drag and without drag. And I found out that the model which considered drag was much more accurate to the real world scenario than the one without considering drag. And this is also observable in the graphs here. The dark green one is basically the graph which took drag into consideration. This one is the one which took the real life scenario, and the blue graph is the computational model without taking drag into consideration. And we realize that the one which does take drag into consideration is a better fit to the real world scenario. The errors. In our experiment, we considered the drag force to be constant, whilst in real life it actually changes with the velocity of the object and is also affected by the density of the surroundings. And the ball may have also been under the influence of other forces which were not considered in this experiment. Can the effect of terminal velocity be seen in our experiment? No, because we dropped the ball from a very small height, we cannot exactly see the effect of terminal velocity in our physical experiment, but it is observable in the computational model, which can be observed by changing the time intervals and observing future data. Even if the ball was thrown down with a certain velocity in the downward direction, the terminal velocity would be the same as that of a drop from rest. And this is very clear from our code. We can add in an initial velocity which is a bit higher than the one that we took into consideration. And we can observe that the terminal velocity will be the same in both the cases. This is because the drag force which acts on the body will become equal to the force that was acting on the body due to gravity and the initial force with which we threw the ball. Observations. So in real life, the drag force changes with the velocity of the object, and we can also observe this in everyday life. For example, when we run faster, we feel the wind rushing towards us at much higher velocity than it does when we are walking. The motion of the ball in the x-axis also does not affect its motion in the y-axis, and this is observed by throwing a ball straight down and by throwing some ball in with a certain velocity in the x direction. In both these cases, we observe that the ball will reach the ground at the same time. And I also learned that the density of the object used in this experiment also affects its motion, because as its surface area increases and its density decreases, the drag force acting on it also increases. Thank you.